So now we're going to video example 2. I think there might be another problem I can video as well. So consider the piecewise defined function f of x equals 1 plus negative 1/2 x minus 3 if x is less than 3 and if x is greater than 3. This is a two-piece function. And let's graph our vertical dotted line. We're going to graph that vertical dotted line at 3. And we're going to always like to label my vertical dotted lines. This vertical dotted line is required on any assessment, but is not required. I'm not going to do that. Not required. It's not part of the function, but it is required on your graph. Okay, so I have this piece, and you can do this any way you would like. I'm going to graph this line first. This line that has a slope of negative 1 down 1 over 2. So I'm going to graph this piece right here first. That's a line. And I recall from point slope form, a point on that line is 3, 1. 3, 1. So I'm going to go to 3, 1, but I have to put an open circle because that point really isn't part of the graph, but I'm going to put an open circle on 3, 1. So this is an open circle. And if I were going to, here's what I know I'm going to do. So I know how to get to that point. I'm going to actually find f of 0 because 0 is less than negative 3. So let's, for giggles, let's find f of 0. F of 0 is going to be 1 plus negative 1/2 times negative 3, which is going to be 3/2 plus 1 is 4/2. So this is going to be 4.5. This point right here is going to be 4.5. This guy was 1, 2, 3, 4, about right here. Okay. And now I'm just going to graph the line. Graph the line. Let's graph the line in blue, just for giggles. I want a solid line. And I'm going to know that this point right here is 0, 4.5. So, oh, it's 2.5 because this is 3/2. This is 1.5 plus 1 is 2.5. Thank you for the check. You've done that a couple times, and I appreciate that, sir. You've checked my arithmetic, and I appreciate that very much. So that's going to change the line. I wonder if I can still grab it and move it. Yeah, I can't. It's going to stay parallel. Thank you very much, sir. I appreciate that. So this point isn't 0, 2.5. This point is 0, 2.5, not 0, 4.5. Thank you, Braxton. I appreciate that. So now I'm going to do this line. Boy, I'm messing this guy up. Didn't make any mistakes when I wasn't videoing it. I made all these mistakes when I'm videoing it. Get rid of that thing. I think I'm good now. Oopsie. There we go. There's that line. I'm going to label this piece over here in blue. This piece right here is this line right here. 1 plus negative 1/2. You don't have to label these pieces, but I like to. That's what this purple piece is. And right away, since negative 3 is less than 3, I'm going to use this to find f of negative 3, and f of negative 3 is going to be, let's put him up here, f of negative 3 is going to be 1 plus negative 1/2, negative 3 minus 3, putting negative 3 into that, that's negative 6. Negative 6 times 1/2, negative is positive, 6 times 1/2 is 3, So this is going to be 1 plus 3, which is 4. So, and this is that point right here. If I went over 3, that point right there would be 3 comma 4. Okay. Now this second piece, we learned how to do these in the last unit. Don't make these difficult. So the first thing I want to do, let me erase that. If I were going to graph this, if I'm still uncomfortable graphing a square root, guess what I can do? It's the square root of x minus 2. I can go back here, and you're going to be able to use your graphing calculator. I'm going to clear that out, and I'm going to graph square root of x minus 2. There's the square root of x minus 2. But keep in mind, what part of that graph do I want for my piecewise? I want it where it's greater than 3. So while that domain is greater than 2, so I only want this 1, 2, 3. I only want this part of it. Okay? I'm going to go back here. I'm only going to want this part of it right here. Well, and we can figure out what it is. Hey, what is it at f of 3? Let's figure out what it is at f of 3. We're going to make this part in red. It's going to be the square root of 3 minus 2, which is the square root of 1 is 1. So this point is 3 comma 1. And guess what that point right there is? Wasn't that point 3, 1 it was? So now I can fill in that hole, but it looks like this. It's going to look like that square root. And you would, if you were going to get this correct on a test, you do want it concave down. Thank you. Okay, so we find these function values. F of 4 is going to put 4 into this value right here. 4 minus 2 is 2. It's going to be the square root of 2. So this point right here is going to be 4 square root of 2. Okay? F of 11. F of 11 is going to be the square root of 11 minus 2, which is the square root of 9, which is 3. So way out here somewhere at 11 is this point 3 comma, or 11 comma 3. Okay. F of 1, I'm going to put F of 1 into this guy right here. Because 1 is in this piece. And that one's going to be an easy one to find as well. Because 1 minus 3 is negative 2 times negative 1/2 is going to be a positive 2. So that bad boy right there is going to be 2. So it's going to be 1 comma 2. That can't be true. Oh, yeah, it can. So it's 1 right here. This is that point right there. 1 comma 2. I thought it was negative. All right. So let's go to this average rate of change. How are we doing on time? We have plenty of time. So let's see if it's, yeah, it's legit. Find the following average rate of change in f of x. And it's not asking for, ma'am. You don't, yeah, you can estimate it, or if you want to, or you can just leave it as square root of 2. It doesn't matter. If it was a quiz, I would just leave it as square root of 2, because that's going to give you your exact answer. Make that a little bit clearer. It's not asking you to give a verbal description. It's only asking you to find the average rate of change. So I want the average rate of change from -4 to -1. What the heck is the average rate of change from -4 to -1? If the function is linear, the average rate of change is just the slope. So this one is easy, -1/2. That's the slope of that line. This one is going to be a little bit more difficult because now we're talking about this spot right here. And if I want the average rate of change from 4 to 7, that is going to be f of 7 minus f of 4 divided by 7 minus 4. F of 7, putting 7 in there, 7 minus 2 is 5. This is going to be the square root of 5. Minus, we found f of 4. F of 4 is square root of 2 over 3. This one, you would want to go to 4 decimal places. So let's go to my calculator and find that bad boy to 4 decimal places. So let's go to my home screen. Clear that guy out. Parentheses, square root of 7, or is it the square root of 5? Well, the square root of 5 minus, minus square root of 2, correct? Close my parentheses. That gives me my denominator and divide it by 3. 4 decimal places, 2739, 2739, 2739, 0.2739. Okay? I bet most of you have already done this assignment, or have you? If you have, this assignment is due, you know. I think it's due Wednesday. It's due Wednesday, the assignment that's associated with this graph. Let's jump down and do this guy right here because this has a quadratic. So we're going to do example 4 on the activity. Okay, here we go. We're going to graph this piecewise function, the first thing we're going to do. Well, let's find these function values first if we want to. It doesn't matter. F of -4. Where is f of -4 at? It's going to be this piece right here. Because -4 is less than -3. Let's find f of -4. F of -4, we'll find these bad boys over here. Let me take this guy and slide him over here out of the way. So f of -4 is going to be -4 minus 9. That's going to be 4 minus 9 is -5. So this point is -5. And the point is going to be -4 comma -5. We'll plot that down here when we get ready. F of -3, you're also going to use the top part. So let's find f of -3. -3 is less than or equal to -3. Therefore, f of -3 is going to be -3 minus 9. -3 is 3. 3 minus 9 is -6. So I have 2 points. This is -6. So this is going to be -4 comma -5, or I'll rewrite that one down. -3, -6. F of 0. Where in the world is f of 0 at? Well, 0 is here. 0 is here, so I'm going to use, hey, this is a quadratic. And I'm going to show you how to graph that quadratic without a graphing calculator. So we're going to look at it with the graphing calculator as well. So if I put 0 in that, this is what I'm going to do. I'm going to do this guy in green. I want f of 0. I'm going to use the middle part there. This is going to be -2. 0 plus 1 is 1. squared plus 3, that is going to be 5. So 0 plus 1 is 1. 1 squared is 1. Negative 2 times 1. Negative 2, that's going to be 1, isn't it, Braxton? Were you on top of my arithmetic? That's going to be 1. Yeah. So that point 1 and this point right here is going to be 0, 1. That's part of the quadratic. And now I want to find f of 2. So f of 2, this piece right here is a line. And f of 2 is going to be easy to find. F of 2 is going to be, I'm going to put 2 into this piece. It's going to be 1/5. 2 minus 1 is 1 minus 5. So that's going to be 1/5 minus 5. And that, if I'm not mistaken, is going to be, well, it's going to be negative 4/5, correct? Yeah. Because I'm going to go 5 and I'm going to go negative, I'm going to go add 1/5. So that's going to be negative 4/5. So let's graph this guy. First thing we do before we graph it is we need to come up with our dotted vertical lines. I'm going to need to go to vertical line again. And I want a vertical line at, where do I want that vertical line at? 1. So I'm going to grab that guy and move him over to about 1. I'm going to do that. Man, it's hard to grab those lines. It's hard to grab those lines. Create a new one, a new line of -3. Okay, this is a line with the -1 as the slope. And I know it has a point down here. It has a point -3, -6, -4, negative. -3, -6 is right on that line. So we're going to plot that guy in. Let's put him in red. This guy right here is -3, -6. Goes down 1 over 1 or up 1 over 1. So this is this line. I'm going to graph him in solid colors. And I'm going to color him red. And this is this piece of this graph is right here. And I'm assuming that you can graph lines well. All you really need is one point. This point we found right here. This point is -4, -5. Down 1 over 1. And it goes, if you're going to go down 1 over 1, you could go up 1, back 1. And that's the slope of that line. Now I want to graph this guy right here. And there's only a few things. What's the vertex of that? The vertex of this quadratic, and there might have been an IXL. Were there IXLs, Bailey? You inquired about those IXLs about graphing. Were they in vertex form like this? Were some of them in vertex form? So you had to realize about, and you could have used your graphing, always use your graphing calculator to match it up. Sometimes some of those IXLs are hard to plot the points, aren't they? Sometimes it's a little cumbersome, especially if you don't have a mouse and you're using your pad. Sometimes those IXLs or graphing IXLs can be hard. But this is a quadratic. It opens down, and I'm only looking at, let's do this guy in green. I'm looking at this guy right here, this quadratic. And look how I'm going to write it. That tells me the vertex of this quadratic is -1, negative 2. Negative 1, negative 2. So I'm going to go to negative 1, negative 2. This is negative 6, so it's third 1. That's about the vertex of that quadratic. Okay? And I know it opens down. So it's going to open down. What we need to do, all we really need to do is figure out where that quadratic hits those lines, those dotted lines, and determine if they're going to be open or closed. Well, on both of them, they're going to be open. But you know what let's do? Let's go to our graphing calculator and figure out where it does. So we're going to put this guy right here into our graphing calculator. Negative 2 x plus 1 squared plus 3. I'm going to put that in my graphing calculator because you're going to be allowed to use your graphing calculator. It's going to be, there are going to be times that you're not going to be allowed to use your graphing calculator, but you will a lot. So it's going to be negative 2. How am I on time? I'm pretty close. Plus 1. Let me finish this graph and then we'll quit. You might have to tell your folks back at the high school that we ran over a little bit. So let's graph that. Zoom 6. Make sure it's on a standard window. I cleared that out. So I got the vertex wrong. Oh, the vertex isn't, that's a common mistake. Now, Braxton, you're my arithmetic checker. It's negative 1, 3. This is the 3 of that vertex right here. This is the y coordinate of that vertex, so that was wrong. Seems like I make a lot of mistakes when I'm videoing, doesn't it? Did I burn it? Oh, well. So now, at least I checked it with the graphing calculator. This is the vertex. So let's go to back to my graphing calculator, and I'm going to find out where that quadratic hits 1 and a negative 3. And I'm going to use my table feature on that. Go to my table. At negative 1, we don't care about that. We want negative 3. And we want 1. So at negative 3, they both are negative 5. At 1 and negative 3. So let's go back to my graph. They both are negative 5 right here. And they're both going to be open circles. Oh, let's graph that line goes through 1, negative 5. Oh, and it goes up 1 over 1. That point right there, 1, negative 5 is on that. So that closes this circle. And it goes up 1 over 5. That line is going to look about like this. Where is that thing discontinuous at? At negative 3, y. That's where you have to pick your pencil up. We're going to do the next lesson tomorrow. This assignment is due tomorrow.